Hey guys, we are going to go through the triangle similarity criteria. So there are 3 different criteria that can prove similarity. You guys already learned about why angle works. Essentially, if you're given 2 congruent angles, you know there would be a third congruent angle, and if all 3 angles are the same, then as you scale size up and down, the shape is going to still stay the same. So just as a quick review, I'm going to fill in some additional notes here. Just a reminder, you have a little bit of a space to write notes down on page 14. Wait, let me check. Yeah, on page 14 of your packet, there is a space for each of the 3 criteria. So in the first space, you can write about angle, and then in the other 2 spaces, you can write about the other 2 criteria. So for angle similarity, we would abbreviate that to just AA. Right, we're using abbreviations sort of like what we did during the triangle congruence unit. And what angle similarity says, again, is that if 2 angles of a triangle are congruent, oh no, that's a horrible congruent symbol, I apologize. That's a congruent symbol though. If 2 angles of one triangle are congruent to 2 angles of another triangle, then the triangles are similar. Remember that that's a really bad one too. I'm gonna fix that. Similar. Right. Basically, the sign for similar is just the top portion of that congruent symbol without the equal symbol. If it helps you to write out the word similar for now, please go ahead and do that. Angle could be given to you by symbols marking angles congruent. For instance, these 2 triangles would be similar by angle because they have 2 pairs of congruent angles. I could also give you actual angle measures. If I give you 2 angle measures, you could find a third, so you could do things that way. Let's look at an example. Here we're given the fact that SN is parallel to WY. Remember that symbol means parallel. So I'm going to mark that SN is parallel to WY. Remember, anytime you're told things are parallel, it's so that you can determine information about the angle relationships. If I were to extend these lines out, I would be looking at 2 parallel lines cut by a transversal. So just like what we looked at with triangle congruence, we're going to see things like alternate interior angles pop up again. So I would know that this angle is congruent to this angle. Using this other transversal, I could also determine that this angle here, angle W, would be congruent to angle N. Alternatively, you could have just used the vertical angles happening right here to find 2 pairs of angles, right? You only need to be able to prove 2 pairs congruent, but here I can actually prove all 3. But because of that reason, these 2 triangles are similar by angle. Okay. The next triangle congruence criteria, and this is not one that we've talked about yet, is called side. And this might sound familiar because we had a side criteria for congruence as well. But side congruence for similarity is slightly different. With congruence, the requirement was that 3 sides of a triangle would be congruent to 3 sides of another triangle. But we know similar triangles aren't going to always be the same size. You're going to typically have one smaller and one larger. So when we're looking at this, it's not about the 3 sides being congruent to each other. It's actually about 3 sides of one triangle being proportional to 3 corresponding sides of another triangle. And if that is the case, then you will know that the triangles are similar. Okay. Sometimes when we look at this, it's going to come from actual measures of triangles more likely than just having like markings. So with congruence, you saw a lot of tick marks. Now, technically, we can mark sides as proportionate. You would use like sort of these curvy tick marks. I don't even think this is really an officially recognized symbol, but sometimes if you're like doing a proof, it can be helpful to mark it like this, but you're never going to see a problem where someone is marking sides as proportional to each other. So technically what you would need is like 3 pairs of sides that are proportional. But again, that's in reality going to be given to you by actually seeing measures. Now remember, proportional basically means that the ratios are the same. So in order to determine if sides are proportional or not, we're going to set up a bunch of ratios, set them equal to each other. Since there's 3 pairs of sides, you'll have 3 ratios. So first I'm going to set up a ratio of the smallest, shortest side of each triangle. So here on triangle VEL, the shortest side is 3. On triangle SHO, the shortest side is 18. That fact that those are the 2 shortest sides tell me that those sides correspond. So I can have my ratio of 18 to 3. So I took a ratio of a side on the larger triangle to a side on the smaller triangle. Next, I'm going to look at a ratio of the medium length sides. So I'll be looking at a side length of 4 and a side length of 24. Okay, so my ratio there, again, I'm going to make sure that we're maintaining the ratios order. So before I compare the larger triangle to the smaller triangle, so I want to do the same here. Compare the larger triangle, side length 24, to the shorter triangle, side length 4. And then we're going to do the same with the longest side, length 5 here and length 30 here. So that would give us a ratio of 30 to 5. If I were to evaluate each of these ratios, each one is equal to 6. And since they're all equal to each other, that means that the sides are all proportional. So yes, my triangles are similar by side, side, side. Our last similarity criteria is side angle side similarity. Just like with congruence, we would use SAS to represent that. But again, in terms of the sides, it's not about congruence, it's about proportionality. With the angles, it is about congruence. So if 2 sides of one triangle are proportional to 2 sides of another triangle, and their included angles are congruent, then the triangles are similar. So looking at this, we're talking about positioning being the same with side angle side as what we would have seen with congruence. It has to be an angle between the 2 sides in order for this to work. So let's say we have this side and this side are proportional. This side and this side. The angle that has to be congruent in order for me to prove similarity is this angle right here. And that would give me side angle side. Sorry. Next, for this example, we're told in the problem that angle F is congruent to angle T, so I would mark that. And then I need to figure out if the triangles are similar. So I can see that I have marked information on a side and then an angle and then a side, an angle, and then a side. I need to make sure the sides that are marked are actually proportional to each other. So again, I'm going to set up ratios just like I did over here. The difference is that I only have 2 ratios to set equal to each other. I like to always sort of start with the smallest sides. So I start with the smallest sides corresponding would be 2 and 4. So I'll compare 4 to 2, just, I don't know, give us a whole number. So 4 to 2 is a ratio of the larger triangle to smaller triangle. So same thing for the larger of the 2 sides, ratio of 6 to 3. And again, in this case, you see both those ratios would evaluate to 2. So since 2 is equal to 2, these 2 triangles are in fact similar by side angle side. So to go through a couple examples before we move on, I recommend you pause the video and try these on your own as we go through before I go over them. And then I'll go through them as well. So this first example, we have labeled some side lengths. I'm not given any additional information. I can mark something though. I can mark that angle ACB is congruent to angle DCE here by vertical angles. And then I'm just going to check to see if my sides are proportional. And if they are, then I'll have side angle side. So, and I'm going to start with shorter side of both triangles, so 6 as compared to 12. So, 12 over 6. And I'll compare the other sides, so 18 over 8. Now, when I take 12 and divide it by 6, that would be 2. And 18 divided by 8 is not 2. It's 2 point something. So these sides are not actually proportional. So not similar. Not And then I'm just going to use the similar symbol. Looking at number 2, again, I have 2 triangles here. Triangle ABC and triangle EAD. We'll see if that's the order of naming them. It looks like we're given a side length, an angle, and a side for this smaller triangle. Then we have a side and angle, and then we have the part of this side and then this part of this side here. So in my mind, I'm going to make sure that when I'm finding whether sides are proportional, I'm talking about an entire side of a triangle. So the shorter side of the smaller triangle has a length of 8. The shorter side of this larger triangle is not 5 because this whole entire side length is actually 15. So the shorter side here would be 12. So ratio of 12 to 8. Then when I do a ratio of the larger sides, the longer side of the smaller triangle is 10. The longer side of the larger triangle is this whole distance here, 10 plus 5, which would be 15. Okay, so in this case, I have 12 divided by 8 equals 15 over 10. That is true. Each of those ratios comes out to 1.5, or in other words, 3/2. So my sides are proportional, and I do have an included angle in each that was marked as congruent, angle A and angle C. So I do have similarity. Then I need to make sure my similarity statement is written in the right order. So first had named triangle ACB. So we named point A first. Now point A on the larger triangle actually does not correspond to A on the smaller triangle. A on the larger triangle was between the unlabeled side and the larger side. So between the unlabeled side and the larger side of my smaller triangle is actually E. So I'd name this as E. And then after that, B, which was here at the end of the shorter side, so that corresponds to D. And then last but not least, we'd be left with A. And those triangles, again, are similar by side, angle, side. Sorry, that's a horrible S. And then here we have numbers 3 and 4. So for number 3, I'm given 2 angle measures. I have right angles in each, and then I have a 48-degree one and a 42-degree one. So at first, this doesn't really look like any of my criteria because I don't have 2 current angles, but I can actually use triangle sum theorem to figure out the remaining angles. So if all 3 angles have to add up to 180, with this 91 not included, the remaining 2 angles would have to add up to 90. So 90 minus 42 actually gives me 48. So if I have one 42-degree angle, I have a 48-degree angle. Same thing over here, 90 minus 48 gives me 42. I can't really fit that there, but I'm just going to mark that those 2 are congruent. So I can actually see all my angles are congruent. So in this case, ABC is similar to the other triangle. A, 48 degrees corresponds with T. B, the right angle corresponds with G. And C, the 42-degree angle corresponds with V. So triangle ABC is similar to triangle TGV by angle. And then our last example that we're going to go through is number 4. We got a little typo there. That should just be 1B. We're actually looking at 2 triangles here, but one overlaps the other. So we can see a smaller triangle, or a larger triangle, ABC. So A, B, C. And my smaller triangle would be here, D, B, E. So again, I'm not given any information about the angles. I'm only given information about sides. There's actually going to be 2 ways to prove similarity here, but we'll start with just the sides. So I'm going to set up ratios for the sides. Again, be careful when I have triangles that share sides or parts of sides. Make sure that if a length is made up of 2 segments, you're looking at the entire length. So I'm just going to label to make that easier on myself. Sorry, that's a 12. right? Because 2 plus 4 is 6 and 4 plus 8 is 12. So when I try to look at the side lengths, I'm like, okay, shorter side of each triangle. So 4 is the shortest side here. That compares with a 6. So 6/4. Then I have the medium length side, which would be 6, medium length side 9. So is that 9 to 6? And then longer side 8 compared with longer side 12. And again, I have to evaluate each of these ratios, and each one comes out to 1.5 or 1.5, 3/2, however you want to think about it. So all three are equal to each other, which tells me all three sides are proportional. So these two triangles, are going to be similar by side, side, side. I just need to make sure to name them. So instead of A, B, C, it would be D, B, E. And then I'm good to go. Now, technically, you also could have proved this through side, angle, side, and I'm going to show you why, just in case it's useful in the future. So I was given enough to prove this through side, 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 so I did. But since these two triangles, they actually shared an angle, right? They shared angle B. By the reflexive property, angle B is actually congruent to itself because it's the same angle as part of two triangles. So we use this more with sides when we talked about congruence, but with similarity, we're going to see it happen with angles a lot more when we have overlapping triangles. So bear in mind, if you have two triangles that overlap and share an angle, that angle would be congruent to itself, and you could mark that in. So even if I had not been given this 9, and if I had not been given this 6, I still would have been able to prove similarity. I just would have proved it through side, angle, side instead. Hopefully this helps, and good luck with all your work.